All right, guys, I need to touch base with you on a couple of things as I am checking homework. All right, a couple of things. First of all, I'm going to erase these numbers. Got a couple math contests coming up at Franklin College and Rose Holman. I think I can't remember which is which. They're Saturdays. Anybody's able to go. All you gotta do is let me know you're interested, because I don't arrange for transportation, I don't register and pay the money, I don't do anything until I know I have a team of kids. So if you're interested in going, a couple years ago, Liam Eifert went to Franklin and won. On team one, he was part of the winning team, plus I think he was the top, whatever grade he was in at the time. Anyhow, think about going. If you check your calendar, unfortunately, they are pretty much all day. I mean, we're back before the evening, but they, by the time you take the test in the morning and then have the awards and then drive home, it's later in the afternoon. So if any of you are interested in that, just send me an email, let me know which day you're available, or both, 11/12 and 11/19. Okay, now, homework. Oh my gosh. Okay. So, I can't remember what the directions were here, but you had this polynomial, you're dividing out 2/3, right? Divided it out, got a 0, life is good. Wrote 3x cubed plus 3x plus 3, because that's what we have here, right? And then use the quadratic formula. Now, guys, we did use the quadratic formula earlier on a problem that wasn't a quadratic. But what's the key? It has to be in the form of a quadratic. So a quadratic would look like this. This is a quadratic. You can put anything you want in this parentheses. So if you put an x squared in there, then it's in quadratic form. If you put an x cubed in there, it's in quadratic form. If you put an x to the 1/2 in there, or a square root of x, it's in quadratic form. But you have to have the same thing here as you have here. Is this the square of this? I mean, is this the square of this? No. You cannot use quadratic form on this. Okay? So that's out. So if you guess all your possibilities and nothing works, then just go to your calculator and find whatever the root is that's missing, okay? But don't be using the quadratic on something that's not quadratic. All right, this one, oh my gosh, we butchered this one. So I didn't spend much time on it because you told me you did it last year, but apparently some of us have forgotten. Take Hart's rule of science. I'm just gonna look at my problem. Here's my function, then we got the conclusion, here's my function. Just count the sign changes. So I have one here, right? I'm going from negative to positive, from positive to negative, from negative to positive, and from positive to negative. So I have 4 sign changes. Remember that however many sign changes you have, you decrease by 2. So this could be 4, or it could be 2, or it could be 0. You count down by 2s until you're out. All right, now negative reals. Now I'm going to let x be a negative number, so that will become positive. That is still going to be positive. That's going to become positive. That one's going to become negative, and that one is going to stay negative. If I put in a negative number for x. So there's only one sign change there, not 1 or 0. What do we have to do? We have to count down by 2's. You can't count down by 2's when you only have 1, right? So it's 1. Now, how many roots does this problem have? 5. If there are 4 and 1, then there can't be any imaginaries because there's only 5. If there's 2 and 1, then there would be 2. And if there are none and 1, then there could be 4. Now, somebody put 8 or 6 down here? Where did that come from? How many roots does this problem have? Right. Now, I'm not saying there couldn't be a polynomial that had an 8 or a 6 down here, but not this one, right? Somebody else put, I don't know, 1 or 3 here, I don't know, but anyhow, it ended up down here with 1 or 3. Is that possible?
No.
No. Keep your brains functioning, people. You cannot have an odd number of imaginary roots. Okay? So if that happens, which it doesn't, but if somehow you messed up and it did, you messed up. Go back and fix it. Okay? All right. Quickly, we got time just barely to get this one thing looked at. It's an easy one. The first one is x plus 3 over x minus 4. All right. First of all, x cannot be 4. Would you all agree with that?
No.
So that's your vertical asymptote. X can't be 4. Your horizontal asymptote is the limit. The limit of that is 1. Absolutely. Easy. Now, intercepts. How do we find intercepts? Aren't intercepts where we cross the axis? So isn't one coordinate 0 if you're on an axis? So if you let y be 0, your intercept is negative 3/4. Would you agree with that? If you let x be 0, I mean, if I let x be 0, my y-intercept is negative 3/4. Now, what if I let y be 0?
X would be negative 3.
X has to be negative 3. That's exactly right. That's the only way you're going to have that fraction equal to 0, is if x is negative 3. Now, I want you to think about this one. These dots have to be connected. And the curve is contained by its asymptote. So doesn't it make sense that we have a shape that looks like this? Given that those 2 points have to be connected, and given that these are asymptotes? Now, is that the complete picture? No. There's one on the other side, and it is here. Now, before you start saying, Mrs. Ford, how did you know it was there? Remember, it can't cross this line. The only place it crosses the x-axis is right there. So it can't be down here like this. It must be up here, which makes sense because this is a version of which of your BFFs?
Reciprocal.
The reciprocal function. And they perfectly do sense. Right? There we go. You thought we couldn't do it.